and welcome back to our Pi Day stream here at AWS OnAir. I am Jasmine Kyles. This is my co-host, Darko.
Indeed.
We are now joined by our guest, Suman, and we're going to be going through an entire section here on extending your data architecture to generative AI. So Suman, welcome to the show.
Thank you so much. Pleasure to be here.
Yeah. So Suman, tell us who you are.
Sure. Hello, everyone. My name is Suman Devnath. I work for AWS with the developer relations team as a principal developer advocate for machine learning. And it's almost 5 years now.
5 years?
Yeah.
Yes.
Wow.
Were you at DA for all 5 years?
Yeah.
Wow. Okay, well, there you go. Speaking into the camera for 5 years or at conferences. Welcome. Welcome, Suman.
Thank you so much. Yeah.
Suman, a question for you. What is the best large language model?
That's a very good question. And this is the question that I think you asked me yesterday as well.
Yes.
I still did not have that answer.
Yeah.
Today also I don't have, because we are in a time when things are changing every day, and it is all changing for our good. Right? Mm-hmm. So I personally feel the transformer architecture has changed the whole dynamics of machine learning and generative AI, as we call it today. So to me, I think the transformer architecture and the BERT architecture are the best architecture that I have started working on with, which actually opens the door for all the AI startups that we are going to talk about today, which opened the world to all the developers, not just machine learning data engineers and data scientists.
Yeah.
And you mentioned these transformer architectures. Like, do folks out there, do developers right there behind the camera, people in chat, do they need to know what the transformer architecture is?
Yeah, I think that's a very deep topic to start off with, but in a nutshell, it's in deep learning or in machine learning in general, there are different architectures. There are convolutional neural networks, there are transformers, and so on and so forth. But transformers have changed the whole dynamics. So it has an encoder and decoder blocks, which we will be talking about during the demo. So I'll just touch base on that as we go along.
Yeah.
Amazing.
So you mentioned you have a demo. We definitely want to get to the demo. That is our favorite thing because we get to show builders what it is that is possible within AWS. So what is Amazon Bedrock?
Sure. So Amazon Bedrock is a fully managed service from AWS, which gives you the ability to use different foundational models from different AI startups, as well as Amazon's own foundational models. So you don't have to worry about different partners changing the code based on their APIs. You can just use Bedrock, and under the hood, Bedrock will give you the access to all the foundational models.
Amazing, amazing. So we're going to see the demo today on Amazon Bedrock, right?
Sure.
Should we bring it up right now?
Yeah.
Let's bring up the demo from Suman and have a look at it. First of all, the goal is here, like, what's the quickest way for you developers out there to get started with some data and generative AI?
Absolutely.
So what are we looking at here, Suman?
Sure. So what I thought to show you is first we will spend some time on Bedrock to get started with, and then I will start a use case. Right? So if you are new to Bedrock, once you log into the AWS console, you can just search for Bedrock in the search button, or you will come here, and then you can simply click on Get Started. So once you click here, you will see all these different foundational models. And once you are here, you can select different options here to get started. So you can either click on text or chat, or from the home page itself, you can select different vendors. So now, in this chat, I can select any foundational model. So let's say Anthropic, and I think we just recently added Sonnet and Haiku. So let's select Sonnet.
Okay.
And
so these are different foundational models that we have here.
These are different foundational models.
What is a foundational model? Tell the chat.
Sure. So traditionally, in machine learning, we had different models which solves different problems. So we had a different model to do text summarization. We have a different model to do, let's say, a Q&A. There are different models for image recognition and so on. So during that time, when we train those models, we have to give the data along with its label, right? So if it's a question and answer, you have to give the question and answer, question and answer. Mm-hmm. So that way you will end up building a Q&A machine learning model. But now, if you think about it, we will have different machine learning models solving different problems. Now, that was working pretty good, but what researchers found was, why don't we do something? Why don't we make some model which understand the language? And once you understand the language, you can solve all this problem by doing some kind of fine-tuning later on. So large language model is different from a traditional machine learning model in a way that in large language model, you don't need the data with its label. You just give the data.
Yeah.
And that data could be the entire Wikipedia data, the internet data, all the books that we have. And what you end up getting is, like if you see here, the Sonnet model or any model from
Sumant, can you make your screen full screen? Just hit the big green button there and just Command plus it a couple of times so we can see it easily.
Sure.
Or that. Yeah, there you go. Beautiful. Thank you.
Okay, perfect. Yeah. So when we talk about large language model, we give unlabeled data. That means we are just providing all the data on the internet, and we end up getting a very big model with millions of parameters and billions of parameters, which actually understand language. So all these models that you see here, Sonnet, Amazon, Titan models, and all of that, these all are trained on unlabeled data.
Okay.
Yeah.
So the whole internet.
Absolutely.
I don't know. We have the whole internet here, just so you know, and this is, well, it's not trained on the whole internet, but probably yes. Okay.
Sure. So let's try to. So once you are in this playground, you can start asking questions. So today is Pi Day, so why don't we ask something interesting? So we can say, write a poem on AWS Pi Day.
Okay.
Okay. I tried this last evening. It got some very interesting answer. Okay, so it's a little squished here, but you can read it.
But it's easy, like this is running right now on Bedrock, on Amazon Bedrock, this whole service that does this. Suman just sent a prompt, a query to the model here to make a song on Amazon or on Pi Day. Now, of course, probably this doesn't know what Pi Day is.
Right.
I see a lot of actual pi, the number. But it's great. Like it gave you this thing. Like, can you do something else? Can you ask it something else?
Sure. So we can say, what is pi?
What is pi? Okay.
So pi is a mathematical constant. So it actually, and if you look at it, the speed is fantastic, right?
Yes.
So it was not like this before when we started off with large language model, but as we progress, we see a better performance and the better model accuracy as well. So that's how you can get started with Bedrock from the UI. And throughout the day, we are going to show you how we can do this through the code, which might be more interesting for developers.
Like it. So, Suman, we have a question here for you in the chat. And I think I asked you similar to this. Lobor Nasio is asking, what's the most popular model people use today?
Yeah,
on
so
Bedrock?
so I think it all depends on your use case because different models comes with different trade-offs in terms of the number of tokens, which in layman's term is basically how big your question or prompt could be. So it depends upon that as well as the cost or the price that different models have a different way of charging. So you might have to check on that. But in general, there are different benchmarks that have been done, and this is a very evolving domain as we speak. People have not fundamentally tested all the models for their use case, but I personally feel if you are looking to get started, you can start with Claude or Mistral, which we have recently announced, and that has got a very good positive feedback from the community. Yeah.
Amazing. So what else do we have in the demo?
Sure. Yeah. So now, I just thought to give some brief about Bedrock, but the first demo which I wanted to show you is on something which we all aware of, like S3, right? We talked about S3. So what I will show you is that imagine that you already have your data on S3 and that you are doing it for some analysis. Right?
Okay.
Now, without moving the data anywhere else, how you can integrate Bedrock with that? Right? So it has nothing to do with Bedrock as of now, but we will see how this transition works, and it's extremely smooth. Okay? And then throughout the day, in the next demos, we are going to see deep dive on few of these concepts that we are going to show now. Okay? So here, if you see this, we have an S3 bucket called YouTube ETL, and in this bucket, I have lots of data about different YouTube videos. And those contains different statistics like how many likes it got, how many dislikes, and so on and so forth. Right? Now, this project I did to analyze which are the topmost channels or which videos are the best in different regions. Now, what I did initially was I used AWS Glue, which is an analytics service within AWS, which helps you to extract or clean the data using some frameworks like Spark or Ray, right? So if you're not aware of all of this, Glue can simply take your raw data and convert it in the way that you want. It could be in an efficient format like Parquet and so on. But idea is you just come to Glue and create a crawler which will go to your data, which is in S3, and create the schema. Because ultimately, I need to query that data. And the data is in the form of CSV file. I cannot query it directly.
Right.
So I have some databases here which I have not created. The crawler has created. And ultimately, if I come to this query editor, I can just run this command, like select all from my database where region is US, because the data set contains lots of different regions data.
Yeah,
and
so now you've moved over to Amazon Athena.
Athena, right.
Okay.
So what we essentially do is after we create the schema on the data using Glue, we come to Athena to query the data, because ultimately I wanted this. Glue just helped me to prepare that data so that I can come here and run some interesting queries. Okay. Now, if you see here, we have lots of different details. A few of the details we may not need at this point, but we have title, different YouTube channels, how many likes, tags, and so on and so forth. Now, this is good, right? I wanted to go to the next stage in my data pipeline where I wanted to clean the data. At this moment, the data is not that cleaned. So again, I used Glue, and in Glue, we have something called ETL jobs, right? And it's basically, you can give your data, you can write the Spark code, or Glue can automatically write the Spark code for you, and ultimately it will create a clean data. So here is the job that I have. My data is split into two different S3 buckets. Okay. In one of the bucket, I have the raw CSV. In another bucket, I have some schema attached to that. Okay, these are the raw data which I got. Okay. So I just took those two data. I used some mapping. So in this case, I just did some inner join, and I have not done that. Glue has automatically done that. I've just said what I want, and ultimately, I have saved the cleaned data on S3 bucket. Okay. Right? So this is the data that I have in on S3. Everything is processed. So now comes the interesting thing. Now with this data, what I can do is I can go to QuickSight and create dashboards. Right? So here, if you see, we have a small dashboard which says these YouTube videos are from which different domains, like travel, science and technology, and so on and so forth, right? So imagine that you are in this stage where you have processed the data, everything is done, and now you want to leverage Amazon Bedrock or large language model to extract more information from this data. How can we do that? So now you can come to Bedrock, and you don't have to worry about how all these things work. Okay. So what we will do is, we have seen earlier that you can simply ask a question and you will get a response. Yeah. But in this case, the data that I have is my own data, right? So if I simply ask this question to Bedrock, Bedrock won't be able to answer.
Of course, it doesn't know.
So there is something called a RAG, or retrieval augmented generation. Okay. So we will get into that later on. But in this, what we have to do is you can come to knowledge base.
You just missed it. There you go, knowledge base.
Knowledge base.
Okay.
And here, you simply click on create a new knowledge base. Okay. You can give some name. So you can say YouTube KB. And simply click on next. And now you have to select your S3 bucket where you have your raw data. So I can give my raw data bucket. So let's say this one, and click next. And now I have to use some embeddings. So embeddings is, that data is in plain text, right? Okay. English language. Now large language model do not understand that. I have to convert that into something which large language model understand. And that is what embedding helps us to do. It just converts all the data that we have, and it will create something called vectors, or array of numbers, we can think of it. Okay. So I can simply select one of the machine learning model or large language model. So this model is not for interaction for the chat. This is just to convert the data into embeddings.
Okay.
Once that is done, I have to store those embeddings, right? So we can use our own vector store, and we will go deep into this later on in this day. But as of now, you can think of it that I'm just storing the data in a format which large language model understand.
Okay.
So I can just simply select this option, and it will, under the hood, it will create OpenSearch, and which is a serverless service that we have, which you can use as a vector store. You can always use some other vector store of your choice, but let's select this, and that's all. So we can just simply click here, and it would create the embeddings, store those embeddings, and all of that. So I'm not going to create this because I have already done that. So if you see here, I have my knowledge base, my KB YouTube.
Okay.
So at this point, I can ask some questions. So here, I can select the large language model which I want to use. If you see here, we have version 1, version 2, and so on. So let's go with version 1, and let's ask some question. So which are the top channels that got the maximum comments? Okay, so this is the question that I'm asking, which the model doesn't know, the Claude doesn't know. But see this, is able to answer that, okay, a few of the popular regions in US regions are SpaceX, Mr. Beast, and so on, right? Okay. Now, how do we validate this is true or not? So now let's go back to QuickSight. And now let's quickly create a dashboard or a chart using the comment count.
So this is a dashboard speedrun. Okay, Suman, go for it.
And if you see here,
look at that.
Sorry. If you see here, we got this Mr. Beast and then primitive technologies and so on. So this is happening because I have set up my entire workflow. But what Bedrock is able to do is now you can get more insights from this, and you can use this to do different things which might be needed for your application.
Yeah, that was awesome. So we got to see you put it into S3 in a bucket.
Yep.
You connected the data with Glue.
Yep.
You went to Athena.
Yeah.
What else?
We went to Athena, we just analyzed that data, and then we wrote a ETL script, which actually cleans that data. And on that clean data, we created a dashboard on one side. On the other side, we used Bedrock to interact with it.
Yeah, nice.
I like that. So please stay tuned. We're going to have a lot more about this topic as well coming up later today. So Suman is going to go through a bit more about what is retrieval augmented generation, how does it work, and how do you set this up even more. So if you want to see more Bedrock goodness, do not go anywhere. And I see your chat. I see your comments. Please do keep them coming in. Please do keep coming. Suman, did you know in chat they call you Superman?
Oh, is it?
Somebody tried to type Suman, but they wrote Superman. But
I take that.
You are a Superman.
Yes.
That's amazing. Chat, I have a thing for you. So I want to show you something. Where is it? So I do have a question for you right now. So I'm going to share my screen, and I want you in chat right now to tell us. I want to tell us, just to make sure you're following. What does the acronym S3 stand for? Number 1, simple storage service. Number 2, storage version 3. Number 3, storage. And number 4, simple S3 service. Put 1, 2, 3, or 4 in chat. I just want to make sure you are following, you're paying attention, and that you all kind of know what it is. So we at Amazon, we love acronyms. That's just our favorite
Absolutely,
thing. We just love it. As a non-native speaker, I am actually absolutely confused by acronyms in America. For a long time, I didn't know what HVAC was. People were like, oh, we have the HVAC here. I'm like, what is HVAC? I'm too afraid to ask. I was well beyond it. But yes, Amazon S3 is storage. I think if Paul is here, Paul, if you're watching us, we should rename the S3 acronym to just storage. Amazing. Okay, cool. Let's actually move on from this. I'm going to flip back to a different screen, and I want to talk to you about something else. Now, Suman mentioned here taking your data, immediate data that you have in an S3 bucket, and using it immediately with some generative AI, right? Which is always great, right? No need to worry about setting up generative AI or setting up anything complicated. You just have your data in a bucket and you do things with it. What about if you had a lot of data? I mean, a lot of data. And you want that data to be shared across your organization. Multiple teams should use it. Multiple engineers should access it. You have different permissions, different policies, all of those kinds of things. How do you, first of all, set that up? Is there a service for that? Spoiler alert, yes, there is. And can you use generative AI to kind of help you figure out that data? So I want to show you something here. It's called, look at my screen. That's not how it's called, but look at my screen. It's called Amazon Data Zone. Now, Amazon Data Zone is just it's a wonderful service that kind of integrates a bunch of data management mechanisms. So from governance to sharing to security. As I said, if you want to share up a lot of data with a lot of people within your organization, Data Zone is the place to go. I'm not going to go into the basics of what Data Zone is and how to use it. I want to show you a feature of Data Zone. So what I have here is a project in Data Zone. I'm going to zoom into my screen just to see it better. I have a little project, I have a little environment here that has, or will have some data in a second. So I'm going to bring up this thing. We're going to go back to our good friend Athena to add some data into our data environment. So open Amazon Athena, look at that. Beautiful. Right, so I need to go and find a query. I have a little text file here with a query I'm going to copy paste. And I'm going to paste this. This query is just going to create a table called PMT NTSL ONL _US, and it's going to create a bunch of rows and data for it. RNG, CNTR _CD, US. Great names for table rows. Wonderful. I'm going to run this, and hopefully it's going to work. That's right. Okay, good. It's completed. And I'm going to show you something. So if I go back to my Amazon Data Zone here, look at my data sources. There should be one. Here's the data source. This is my Amazon Athena data source. I'm going to run the sync, so it's going to be basically pulling the data from here, so we can have this as a little, basically a data asset. So clicking on this thing, we open up our data asset, and there's a few things to see here. Now, what this thing does, it's called AI Recommendation Descriptions for Amazon Data Zone. I know, rolls off the tongue. But what this does, it actually uses generative AI to help you decipher a couple of things here. Number one, it actually suggested a name called Payments Online Using. What it did, it took Paymentisse Online Use as a name of the table and kind of figured out that could be Payments Online Using. Well, maybe. I don't think it's using, it's actually US. Save, nice, cool. But it did help me. If I look at the schema, it actually is good to take RGN and take that into a region. Country, it's a country code, user ID, date, payment method. So it's able to determine these things, what those things are, right? It's kind of able to give you those descriptions for these various rows, even though they're named weirdly. It can kind of do those things for you. I can accept these things for these things to be kind of, well, look at it, it's gonna change all of these things. Nice. One more thing, and this is going to take a couple of seconds. I can click Generate Descriptions. Basically, this is going to use the AI recommendations to generate descriptions for this specific data asset. If I click this, it's going to take a while, but what it's going to do, it's going to generate this wonderful little summary of what this data set is. And why is that useful? Suman, why is this useful? Why should people have nicely, not labeled, but described data?
That's the most important thing when it comes to machine learning, because it's always garbage in, garbage out. So you need to make sure that the data is nicely labeled so that the machine learning model can understand. At least this is very important from machine learning standpoint, but elsewhere as well, this is very much important.
Exactly. And even if we go beyond machine learning and talk to developers, data users, data consumers, if I give Jasmine this data set, here you go, Jasmine, figure it out. Jasmine's going to spend a lot of time potentially just like, what did you give me, Darko? What is this?
I don't know what this is.
I don't know what this is.
She said this anyways.
I don't know what this is. So, but if I had a nice little description of what this data is, if it can if a thing could understand what this data is, would be really, really useful. So this is exactly what this thing is doing. It's going to generate, it takes a second. It's going to generate this wonderful description of what this data set is. So, and that is critical. Specifically, in a large business organization where you share this data across not just 3 people on a Twitch stream, but multiple organizations, accounts, teams, groups, and all of those fun things. I've been told we have 3 minutes left, or 3 minutes left until this thing is generated. Just so you know, it takes just a while. It's processing this data, it's running it back on some machine learning model. I don't know which one actually, but it is going to be running this. So bear with me while this thing goes through. While that is happening, chat. Do you manage a lot of data? Do you have to share a lot of data as well? If you do, I'm sure somebody's going to throw a link in the chat right now about Amazon Data Zone. Definitely do check that out because data governance, data management, data permissions are something we can all strive for. And would you look at that? Review generated data. So this is the description we got from Generative AI. It's going to give us a summary of what this data that I've created actually is. So if you see here, the payments ONL US table contains details about online payments made by users. Data provides insights into payment patterns across different regions, countries, and payment methods. Wonderful. Just
awesome.
All of this data is here. All of this thing is kind of separated. Data analysts, data users can just kind of go here, look at this, and be happy. We all want to be happy, specifically when we're dealing with a lot of data.
This was almost 2-3 weeks' time, traditionally, if you have to do it. Yeah.
So how would this be done in the past?
It was very, very difficult. You have a different pipeline, there are different teams who manages, a team who will extract that, just like how I did using Glue and Athena, and then you have to integrate with machine learning. So it's we take it for granted these days, but this is an enormous work by very smart people that we have.
Yeah, and this is transformative.
Absolutely.
That is no small feat of how much time you just said could possibly be saved that would free up your time to go work on anything else.
Absolutely.
Yeah.
Remember, folks, Generative AI is here to help you not have to do these boring things. So this is definitely not a fun job. I wouldn't like to just go and look at a data schema and some data and try to figure out what this is. Now, bear in mind, this may not be 100% accurate. So you still have to understand, like, okay, does this description make sense? And most of the time it will. So definitely that is good.